Alright, so for our first project here, slash experiment, slash messing around, you're going to want to pull out your centimeter ruler. We're going to use this to make sure that when we're looking at our measurements, we have something to compare to. And it's the same in all of our bags so that we can compare our measurements to each other. I've got the magnets, which come wadded up in a little bit of blue tape so they don't stick to everything and get lost. And I also have paper and a pencil because I want to record my observations. If you have a super amazing memory, good on ya. You can maybe remember what magnet does what, but I am definitely not going to remember, so I'm going to write down my findings. If you have other things that are also magnetic, I've got the paper clip from the bag and also this nail we might use, or even any extra magnets from your refrigerator. We can use pretty much anything for this experiment. But we're going to start with one object lined up at the end of the ruler. I've got a paper clip to start with, and I want to keep track of how good the black magnet does, how good one tiny silver magnet does, and how good two silver magnets stacked on top of each other do. So I'm just going to take a magnet and start pushing it slowly down the ruler until I get a reaction from the paper clip. Getting closer, getting closer. Doop. Alright, so it looks like in order for the ceramic magnet, which is the black magnet, to stick, they need to be touching each other. So I'm going to write that down. I'm going to try the same experiment, but with one silver magnet. It's also sometimes called a neodymium magnet. We're going to do the same thing. Push it a little closer. A little closer. Whoop! Oh, there it goes. And this one went about a centimeter. So this magnet might be a little bit stronger than the other magnet. Now, I'm going to guess if I have two of these magnets together that it might be even stronger. So let's test that hypothesis by pushing these two magnets closer to the paperclip. Nice and slow, trying to keep track of how far apart they are when they doop, finally stick back together like that. And it looks like in that case, my hypothesis was correct, that the two silver magnets were the strongest combination so far. So now if I want to change something in my experiment, instead of putting a paperclip at the end, I'm going to put a magnet at the end and see what happens when we try magnet versus magnet. Alright. Oh, we got a push that time. Interesting. And that didn't happen with the paperclip. So we've discovered something new. What if I flip my magnet over? Does that change our push? Haha. Interesting. So it looks like the magnet pushed further away than it was when it pulled. I'm not sure if that means anything that's going to be important to me yet, but I might want to write it down just in case. So let's see. If it pushed and pulled a little bit differently, maybe I'll take two silver magnets. You can see where this is going, huh? You just keep trying a bunch of different combinations, and either you guess what's going to happen and you're right, so your hypothesis is correct, and that's amazing, good on you, good job. Or your hypothesis is incorrect, and then you get to go, that's weird, I wonder why. So I'm just going to keep trying this with the magnets in the kit, and I also have pulled some magnets off of a refrigerator, so we have a couple different variables, and depending on what magnets you have in your life, there's a little pink donut magnet. Ooh, we got a big push on that one. Depending on what magnets you have in your life, you might have some that are stronger or weaker. You might have some weird things with magnets on them. Pulled this one off of something industrial. This is a huge magnet. Whoa! That looked like it flipped before it stuck. Let's see if we can do that again. Doop doop doo, doop doop doo. Flip and stick. Huh. Might have to do that a couple more times when the camera's off to see if I can figure out what's going on. And even some kids' toys have magnets in them. So this is a random bit of plastic that has